economics of space have never been more compelling, and we really are seeing a rapid transformation of the sector right now, aren't we? So we start the session with the new frontiers of space science. And yes, it's a great pleasure to have you all here with us here today. Mr. Atsushi, very warm welcome to you. Thanks for joining us.
Thank you very much for having me today.
I'd like to start off with you, if possible. Now, iSpace is developing robotic spacecraft and other tech for both transport and exploration missions contracts. Tell us a little bit more about the advancements you're making in the sector and, how space exploration and technology really have evolved from science fiction through to real-world applications.
Okay, thank you for the question. Concerning science fiction, when I first joined the company 3 years ago, when they introduced me to this iSpace, coming from a completely different world, I first thought it was a science fiction, or it's a rich man's hobby, or young engineer's dream-chasing company. But when I look into it, it's becoming reality. It's not science fiction anymore. And I was one of the person already 9 years old in 1969 when I first watched the Apollo 11 mission. So it's already proven technology from my point of view, already 15 years ago. And I don't know how many of you watched the American football game, Super Bowl, the other day. I was impressed by one fact that there was 123.4 million viewers of that game, which was a good game, except the 49ers fan, I think. But besides that, the number one ever for the American viewers was Apollo 11. And it was said to be 125 to 130 million. And if you look at the population, currently, I think American population 303 million, 30 million, whereas at that time, 69, I think it was 230 or something like that. So if you look at the proportion, the attraction that you get for this moon landing is amazing, and that's how people think about it. So it's reality, it's not science fiction, and we're trying to expand this technology to the real world, because now we are living, and we cannot live without this LEO and other satellites. And we try to expand from LEO to the cislunar architecture, and that is our challenge, but we need all the support from, not just from single government, but from all the government as mentioned, and we're trying hard to achieve, to prove by action.
Very impressive indeed. Great to have you here as well. Thank you so much. Kareem, over to you. Give us your perspective on this, the evolution of space exploration, moving from science fiction all the way through to reality and real-world applications. And tell us a little bit more as well within this about the role of AI in the sector, which is very, very important right now. Which areas are also going to benefit the most from this? And tell us what you're doing as well at Space 42.
So from a Space 42 perspective, and Space 42 is the outcome of the approved merger between ESAT and Bayonat, two UAE space champions that will come together later this year. And for us, the four sort of normative technologies that are emerging in space, in the following order, I would put them, and I would conclude on AI. First is the formidable advances in composite material, which is bringing a paradigm shift in how do we manufacture structural elements that are much more resilient, less mass, and more cost-effective in space. Second, our ability to miniaturize and digitize payloads, whether it's for communication or observation. Third, the ability to store and generate power in space. We have to remember that every piece of asset we send in space is on its own for 5 to 20 years. So we have a lot to learn about energy management in space. And last but not least, AI. And AI brings that secret sauce that intersects between improving the productivity of all these elements and greater elements so that we can deliver services more efficiently, more rapidly. Second, AI role in accelerating the ability to innovate new products and services. And most importantly, the role of AI in scaling what we want to do in space. Space remains a very small segment, even when we look at space-related services that are delivered on Earth. It's still for the very selected few. And in the so not distant future, we want to make sure at Space 42 that what we bring from space is accessible to everyone. Look, bear in mind, it still costs $10,000 to send this bottle to the International Space Station. That's a very finite industry. And we need to break the idiom and now make space much more accessible. Now, if we do this right at Space 42, there are 4 things that we're going to achieve very rapidly. 1, we will double the cadence of new applications that will bring to bear to the markets we serve. 2, we will multiply by tenfold the capacity or the throughput of the assets that we will have thanks to AI, digitization, so on and so forth. 3 is that we will reduce by 50% the time and the cost of developing new structure, new elements, new system in space. And last but not least is our ability, again, to democratize space applications on Earth.
Thank you so much. Incredible overview there. Thank you for your input there. Right, moving on over to Dr. Ray, just to save a bit of time. Now, we are entering into an era of Space 2.0. How does this differ from traditional space exploration then? Give us a good overview.
Yeah, thank you for the invitation to speak today. I think maybe for the last 10 years or so, maybe 10, 12, 14 years, people have been talking about Space 2.0. And the theory or the theme was better, faster, cheaper. And the problem that they were trying to solve, and I'll separate the problem into 2 categories. One would be launch, and the other would be missions like intelligence, surveillance, and reconnaissance, and other things, communications missions, et cetera, satellite missions. The idea was that we could dramatically reduce launch costs, which, as you just heard, are one of the fundamental barriers to entry for accessing space and using it more broadly. And I think we've been very successful with SpaceX and a person named Lori Garver, who was the champion of this in NASA, who Jim and I know well. So I think that went very well. On the Space 2.0 from a satellite mission point of view, better, faster, cheaper was the argument. And the problem is that if you integrate the area under the curve, the primes who build large satellites that cost between 1 and 1.5 billion understand this. And so there was this argument about whether or not a lot of small satellites conducting a mission and not having a long lifetime would be a better cost, cheaper cost than large systems. And then there was another gentleman who we know well. His name is Michael Griffin. He was a former administrator of NASA. And he took a job at U.S. Department of Defense and Office of Secretary of Defense. And he changed the conversation, because what he said was, it's not about better, faster, cheaper, it's about mission accomplishment. And in fact, Space 2.0 in many missions has the ability to accomplish a mission in a better way than do very large systems. And for me, moving away from the cost argument, because let's face it, especially national security missions, cost is a secondary. Conducting the mission is first. But now when you move it to mission space, then all of a sudden the conversation changes.
So interesting. It's all about mission accomplished, as you mentioned. Right, over to Professor Neil. Wonderful to have you here as well. Tell us about some of the innovation that we're seeing, not just in technology, but also in delivery models, governance, and integration with national policy objectives. What about that side of things?
Laura, thank you, and thank you very much for inviting me to part of the panel. We've heard from colleagues about the sort of innovation in technology, which allows more to enter into space exploration, cheaper, lighter payloads, etc. But there's an innovation and transformation going on as well in delivery, in governance, and in the wider piece, the integration of your space program into your national policy. A good example of that is here, actually, in the United Arab Emirates with the EMM program, which I've been privileged to work with colleagues in the Space Agency. Traditionally, you say, right, we're going to send a mission into space, we're going to gather data, right, how can that subsequently help society? They've reversed it here. It's about the mission is national development. Now, how can we use the space program as a catalyst for that national development? Similarly, for a nation with a relatively low experience in the space sector, traditionally the routes might be pay someone to do it for you, or progressively go through Earth orbits and lunar orbits, etc., before you head off to Mars. Again, an innovative approach. Back to, we will train 100% Emiratis. We will partner that with experts to do that development, that training as a partnership. And if you look at the Space Agency and EMM, very good gender mix, Average age, I think, is about 35. I feel very old when I'm working with them. It's a young community, and it's a community that's working with society, looking for those economic gains and those scientific and entrepreneurial approaches. Success is measured not in, dollars out, but more about how is it transforming society. And I think it's early days, but we're already seeing sort of 4 areas: science advancement, space economy, national development, and global opportunities progress. Now, such approach won't fit everybody, and one size definitely doesn't fit all, but for a nation that's trying to engage in that space program, to join that 70+ nations rather than the original big 3, then this is an innovative approach, and it shows that innovation is beyond just technology.
Yeah, because as soon as you think of innovation, you immediately think of technology, don't you? So it's very interesting to see that sort of side of things as well. And as you mentioned, you very interesting led the UCL study on the Emirates Mars mission back in 2019. So wonderful to have you here. Mr. Atsushi, back over to you. Now, it's been said that higher investment, improved infrastructure, and digital technologies will unlock serious potential within the space sector. So when looking a little bit more about the technology side of things, give us some more examples about the revolutionary technology that's going to change this space.
Okay, thank you very much. Together with our clients, payload clients, and the partnership clients, we are trying to innovate new technology and we are trying to create a cislunar economy. One example is in our Mission 1, which we launched in 2022, December. Unfortunately, it was a hard landing, which happened in April 2023. One of our biggest client was MBRC, the local rover, which we really appreciate, and that was a very innovative collaboration that we were able to do. And another one was a Japanese company called Nitera. They were sending a solid-state battery for future energy things. In Mission 2, we have one client in Japan, Takasogo Thermal company. They are sending this electrolyzer to split water to hydrogen and oxygen. As a Mission 2, which is planned to be winter this year, we are bringing water from the Earth. However, in future, of course, they try to experiment that on lunar surface so that if water is there, we can try that. And also, we do have other equipments from a radiation probe or other equipment that we're trying to send. And I'm sure that will be a good first step for future innovation in terms of technology on cislunar economy.
Very, very exciting indeed. We very much look forward to seeing how that progresses. We really do. Dr. Ray, I wanted to go back to you just for a moment. I wanted to talk a little bit more about space tourism, because you can't talk about sort of new frontiers without talking about space tourism. I was reading, this goes back as far as 2001, when Dennis Taito was the first ever space tourist who paid $20 million apparently to go up. There are a lot of programs, missions, contracts in place for space tourism. So at what point are we going to see a space tourism revolution?
Yeah, so I think the estimate is that in 10 years we'll see a multi-billion-dollar space tourism industry. I refer to this as the battle of the billionaires at this point, and so I think we've got to move beyond that. But I think if you look at for me the challenges are safety and cost, and I think an analogy might be air travel. So air travel in the early days was very dangerous. You had a finite % chance of being in an accident, whereas today there's almost no safer form of transportation than air travel. And when there are accidents, they're tremendous, but they're very rare. We can go a year without having any, sometimes maybe 1 or 2. And so I think the same is true for space tourism. I think as industry begins to make investments and we move away from the battle of the billionaires, the technologies are there. I think that's the important thing, that the technologies are there. Now it's a matter of commercializing these capabilities, bringing the costs down so people don't pay hundreds of thousands or tens of thousands for the opportunity. And then I think we'll see the industry prosper. Maybe the multi-billion in 10 years is a bit of an exaggeration. I guess we'll see, but I think it will happen.
Very, very good to know, and very exciting that the average Joe might be able to go up into space at some point, getting those costs and getting those safety levels correct, basically. Kareem, back over to you. Coming back down to Earth for a moment. Now, satellite technology plays a vital role in providing many solutions to today's climate challenges, as we know, as well, of course, as greater connectivity to underserved populations, as well as an array of other, many other things. So tell us a little bit more about how space technology is benefiting us here on Earth.
Look, the end goal that we have in sight is how do we, as a space industry, along with other technologies, improve productivity growth in the economies and the societies we serve. And to put this into perspective, and there's in fact a study that the World Government Summit is releasing today with strategy and on this particular topic. Innovation and technology as an intangible asset is one of the 6 determinants of productivity growth. If you take the GCC alone and you bring productivity growth, innovation and technology to the level that is commensurate with the potential of these economies, so you raise the bar that we deserve in this part of the world, the upside is close to $3.5 trillion of incremental GDP over a 10-year period. Now, to put this into perspective, this is 5 times the size of today's UAE economy. Now, I'm not saying that Space 42 is going to do that. What I'm effectively saying is that each technology player has a role to play in this particular arena. And in fact, the example that His Excellency Kusaibi gave earlier today, which is the platform, the geospatial analytics ecosystem that is being put together through a common marketplace and is using the Space 42 through Bayonat's GIQ platform, is a case in point. So this is a formidable tool that is AI-powered, that has multiple applications, that will be able to fuse data and deliver exceptional insights to domains such as environment, agriculture, urban planning, transport, asset management, defense, crisis management. And all of this will improve the productivity of the society and the economies that we serve. So that's really our target.
So interesting to see really how much, there's such a huge impact on what we're doing here on Earth. So very exciting to hear what you're doing as well. Professor Neil, final question for you. Sadly, we are running out of time. We've spoken a little bit about innovation when it comes to governance and different areas as well, but how do we strengthen international law? This is something we're going to be speaking on our panel, our next panel, in fact. But what sort of legal frameworks do you feel still need to be developed, for rapid innovation across technology? How do you keep up with that?
We've talked before about the importance of space. Many of the challenges we face today, the answers lie in space, and for a number, we can only find out what's really going on through space. Climate change, agriculture, for example. And if we're going to exploit space to the maximum potential to achieve that, we need to be able to assure people that they've got confidence in as a safe operating domain in which to do so, whether it be nations, whether it be commercial sector, or society as a whole. And space, like many of the other domains and global commons, has the same problem. Many of the rules and guidelines that were written for that domain were written a long time ago, with many different players in the program, and they need to evolve. And that's really very challenging, as we know. But the framework, I think, it needs to be comprehensive. It needs to have long-term objectives, a commitment to transparency, freedom of navigation, about sharing resources, sharing data, a lot to be done about debris and what happens when you launch, and space traffic management as a whole. Now, achieving that's going to need a bit of a carrot and a stick. The policymakers have got to decide that, but they've got to engage with all the actors, all the stakeholders, both in the thinking about those processes and then when evolving the potential rules and guidance, ensuring that it's fit for purpose, and not just fit for purpose today, but fit for purpose for the future, and that's the real challenge. But unless we do that, we cannot provide that safe assurance that ensures that people will operate to the maximum.
Thank you so much. First and foremost, I'm so impressed that we've kept to time, our 20-minute slot. Thank you so much. That was absolutely brilliant. We packed so much in. There is no shortage of ambition. We are so excited to see how this sector progresses, and we cannot thank you enough for joining us and sharing your wisdom with us here today. So, ladies and gentlemen, let's hear it for our panel. Thank you so much.
Thank you.